Hey, everybody.
Hi.
Good to see you. Here we come. Are you all having a good day? Wonderful. Me too.
Yes.
Me too. Anybody have any questions or anything they want to share with the class? If you have anything exciting happening in your life, that's always fun to have, people to share it with. Larissa.
I want to show you this.
Oh, look at your baby. Hi, kitty. Oh, that's so cute. What's her name? His name?
This is Mr. Monk.
Mr. Monk. From the TV show?
Yes.
Yeah, I like that show. Oldie but a goodie. Yeah, that's adorable. Shiloh.
I actually have a horse show coming up this weekend.
That's cool. Do you compete?
Yes, I can. I ride competitive dressage.
Wow, that's wonderful.
Yeah.
Shiloh, I live right near the Devon Horse Show. You probably know about that one.
Oh yes, that's
Yeah, I go to the Devon Horse Show every year. It's very cool. Yeah, so that's really wonderful. Well, good luck. I hope you do well.
Thank you.
Yeah. Horses are amazing animals. They're so beautiful. So my little dog, you guys have seen my little dog. She when she was a puppy, she loved watching horses. She still does love watching horses on TV. So whenever there's like I want to keep her quiet, I just turn on a YouTube video with horses and she loves it. So the first time I went to the Devon Horse Show, I took her with me and she was terrified. She loves watching them on TV, but in real life, no thanks. They're too big. Well, now I've taken her for the last 3 years and now she loves it. She really likes the horses. She isn't affected by them at all. We get used to things, don't we? Larissa, is that a different cat or the same one? That's a different cat.
It's a different cat.
Yeah, you have 2 of them?
3.
3. Wow. Yep.
Yes.
All right. Enoch, are you raising your hand or? Okay, no.
We went to the Virgin Gorda baths.
Wow. Well, that looks beautiful. Look at those rock formations. Perfect time to be studying rocks and minerals, right?
Yeah.
All right, we're going to go ahead and get started. Let me share my screen with you guys. So hopefully you got the message, messages plural, and I talked about it last week. We're going to be doing some examination of minerals today. So if you were able to get the mineral kit, that's great. If not, you can also just test rocks from your yard. So if you didn't get that message, good, Dominic, I see that. Larissa, if you didn't get the message, it means that you haven't verified your address. So go back to the assignment that's in course information and it'll tell you how to do that. Just make sure that you do. Okay, I have a couple pieces of business that I want to talk about before we start in learning about the minerals. You guys can all see that, right, where it says minerals? Okay, good. All right, so I want to talk about the time zone differences that we have. So you guys know AIM Academy is set for Eastern time, and we don't have any way to set it for different time zones. We have to pick one. So for those of you guys who live on the West Coast, that means your due date is actually 9 p.m. on the day that it's due, not midnight. If you live in Central time, it means it's 11 p.m. and not midnight. And there's just no way that I can change that. But I post all of your assignments at least 2 weeks, usually 3 weeks in advance. So I feel like that gives you plenty of time. So those 3 hours shouldn't really make a major difference for you. Just make sure that you are keeping in mind the time difference. And I think a good idea is to plan to always be at least 1 day ahead. That way you don't have to worry about getting it in by 9 o'clock or 10 o'clock or 11. And always remember that I don't take off points for assignments after the due date. So if you turned in at 5 minutes after the time ends, it's not a big deal. You don't lose any points for that. Okay, next thing I want to talk about is grammar. I've been mentioning this a little bit. It's important. So I'm going to start grading for grammar. It's not going to be a major part of your grade. It might be like a quarter of a point if there's a big error, lots of errors. grammar and spelling errors in your assignments. But I want you guys to learn how to communicate effectively, because as scientists, we want to be taken seriously. When other people read our work, they have to be able to understand. It has to make sense, and it has to be good grammar, because otherwise they're just not going to take us seriously. And here's a couple little funny reasons that grammar matters. The first one, Grandpa is dinner. The second one, he's being invited to dinner. So just having a comma makes a big difference. And this one, a panda eats, shoots, and leaves, right? Unless it's a tactical panda, then it eats, shoots, and leaves, right? It eats and then it shoots and leaves the building. So what am I going to look for? There's only 3 things that I'm going to be concerned about when we're talking about grammar. The first one is capitalization. So you want to capitalize the first letter of the first word of every sentence in English. We always start with a capital letter, always in English. You always want to capitalize the personal pronoun I. Now, I know when you're texting or you're just typing into a chat box or something, a lot of times you won't capitalize that. And that's different. I'm talking about school subjects. So like when you're typing into the chat box here, it's fine if you don't capitalize your I. But you want to do that when you turn something in for school. And then capitalize the names of specific people, places, and things, and only those. So, you know, if right in the middle of a sentence, one of your quizzes, there's a fill in the blank, and the word that you're supposed to type in is sedimentary for the kind of rock it is, you can't capitalize sedimentary. That's not a specific person, place, or thing. So if you capitalize where you shouldn't, you could lose points on there. If you don't capitalize where you should, you could lose some credit on that one. So capitalization, that's number 1. There's only 3. That's one of them. The second one is use full sentences when you write, especially the tests where you have to write out your answers. You want to use a complete thought, a full sentence. Every sentence has 2 parts to it. It has a subject and what we call a predicate. Usually the predicate is a verb, like an action word. So every sentence is going to have that subject, it's here in red, or the verb or predicate. So bloomed, the flower bloomed. The subject is the flower, bloomed is the verb. Even something that has just 2 words in it, like Bob painted, that's a full sentence. But you need to have your subject and your verb in there in order for it to be a full sentence. That's 2 things. Capitalization, full sentences. The third thing then is punctuation. Sentences always end with something. They end with a period or an exclamation point, or if it's a question, you might end with a question mark. So these are the most important ones. These are the grammar rules for my class. There's lots and lots of other grammar rules. When you take an English class, you'll get all those other grammar rules. These are the most important ones for my class, so they're the ones that I want you to make sure that you do. And I will let you know when you don't, and I will, if I see a pattern, I will start taking off some points for that. Any questions? Okay. Please do not reply to my grading comments. What that means is, let's suppose that I'm doing my grading and I write, great job, Ruby, you got 100% on this exam. And Ruby clicks the reply button there and sends it back to me and says, thank you, but I had a question about number 4. Canvas doesn't tell me when you guys do that. When you click the reply under one of those grading comments, I don't get any message. I have to actually go in and look for those. And I can do that at the very beginning of the year when there's only a few lessons, but now we're getting to where there's a lot of lessons. And for me to go into every one is just not possible. So when you want to write to me, no matter what it is you want to write to me about, start a new Canvas inbox message. That means you go over on the left side of the page where it says inbox, click there and just send me a message through there. When you do that, I get your question immediately. It actually comes to my phone. So even if I'm not sitting at my computer, I'll get that message and I'll be able to help you as quickly as I can. Basically, if you write to me, if you ask me a question and I haven't responded to you within a day or 2, that means I didn't get it. I always get back to you at least within 2 days. Sometimes over the weekend, it might be that full 2 days, but I make that my priority, is answering student questions. So I will get back to you. If I don't, write again, try it again. All right. Then finally, I want you to number your exam answers. So I've had a lot of problems with this in all my classes. And I don't think there's been much in this one, but please use the numbers that I have given the questions. So if I've got 7 questions on an exam, make sure you have 7 numbered answers in your exam. In fact, I'm going to show you how I would like you to format your exams. This is perfect the way I'm going to show you. This is from my life science class, but it's a really good example to show you a good way to format the exam. So see how number 1, that's the question in bold, and then the answer. Number 2, the question's in bold, and then the answer's right underneath it and in bold. And there's space in between. So they're not all clipped together. They're not all one big paragraph. It's all separate. You can see there, the answers are not bold, the questions are bold. Got it? Any questions about that? All right. So since we are studying about geology, about rocks and minerals right now, I thought that it would be nice to have some jokes about rocks and minerals. So here we have one. The girl in her exam, it says, name the 3 types of rock. Classic, punk, and hard. Should be sedimentary, metamorphic, and igneous, but those are rock music kinds. All right. So a geologist is, of course, what we call a scientist who studies rocks and minerals. Where do they sleep? On bedrocks. How can you tell if a geologist is mad at you? He gives you the cold shoulder. Cold shoulder. What is a geologist's favorite restaurant? Nobody? The Hard Rock Cafe, of course. Yeah. All right. So let's talk about minerals. You guys started the unit about minerals last week. You'll finish it up this week. And if you brought your mineral test kit, now's the time to get it out because we're going to be doing some testing of minerals. Then next week, we'll do the same kind of things a little bit. We won't spend as much time next week, but we might be able to test some rocks too. So if you picked up your rocks from outside, you can use them. If you weren't able to do either, you can just observe. That's fine. I'll show you what I'm doing with mine. So you can test today either rocks or minerals or both if you want to. But just remember what rocks are. Rocks are made of minerals. So here's what something has to be in order to be a mineral. It has to meet these requirements. It has to be naturally occurring. That means not made in a lab. It has to be inorganic. That means it can't have come from something living. It has to be solid. It can't be liquid or gas. It has to be solid. It has to have a crystal structure. And it has to have a definite chemical composition. Okay, that's what a mineral is. So then, what's a rock? Anybody? If a mineral meets those 5 requirements, what's a rock? How are they different from one another? Khalil?
It doesn't fit those 5 requirements?
Well, kind of. You're on the right track. A rock is actually made up of minerals. So it kind of has to meet some of those requirements, but there can be other things in there too. So a mineral is like the building block, and a rock's what you get when the building blocks come together. But it's not just minerals. It might have other things in it too, besides just the minerals themselves. So yeah, exactly. Larissa.
It can't do as many things as minerals can do. Like minerals can, like with the scratching test, it actually makes like a design or something, and it's not as colorful.
Some rocks are colorful. Some minerals are colorful. So yeah, they're different from one another. Basically, we can think of it like this. Think of a rock like a big cookie. All right. So a mineral is one of the ingredients that's in the cookie. Right. So there might be a cookie made up of flour and sugar and chocolate chips. Right. Well, a rock would be that cookie. The minerals would be the things in it, the flour, the chocolate chips, the sugar. So a rock is a combination of one or more minerals that have stuck together, and it can have things in it that are not minerals too. All right, so we're going to learn more about rocks next week. But since rocks are made of minerals, we study minerals first because we have to know what minerals are before we can know what rocks are. Make sense? All right, so let's spend today talking about minerals. It has to have these 5 characteristics. It has to be naturally occurring. That means it's made from natural processes in or on the earth. No help from humans. We don't make minerals. It has to be inorganic. It never was alive. Coal was formed naturally in earth substance, but it came from plants, so it's not a mineral. Has to be solid. Can't be a mineral if it's liquid. Can't be a mineral if it's gas. Has to have a crystal structure and that unique composition. So some minerals are compounds made up of more than one element, but the mineral always has the same elements in it. Now, when we're talking about elements, these are the elements, right? We've mentioned these before. The periodic table lists all the elements. Really cool tool. You'll learn that someday in some class that you take. So an example here is this is a little rock here that's made of pyrite. So pyrite is what we call fool's gold. And it always has sulfur in it, always. So pyrite is a mineral, and it always has sulfur in it. It's got that distinct chemical composition. So this is what we mean when we say it has a crystal structure. It's got particles that line up in a pattern that repeats. So if you were able to look at this gold here and you looked real down where the atoms are, you'd see that the atoms are lined in a particular way in this crystalline structure. So a crystal is a solid with atoms arranged in that orderly repeating pattern. Now there's 2 ways that minerals form. Somebody tell me how they are. Talked about this in one of the lessons. I know a few of you guys have done it. 2 ways. Khalil.
Is it when magma hardens?
Yep. There's 2 ways that magma can harden.
Through temperature changes?
Well, yes. Indirectly, yes. Indirectly. I love the thinking. Dominic.
How slowly it cools.
Yeah. There's 2 ways, fast or slow, basically. And of course, Khalil, that has to do with the temperature. If the temperature is high, it's going to take longer to cool down. If the temperature is low, it's going to cool down faster. So magma cools slowly, giving us big crystals, places where it would stay hot, like under the surface of the earth, where it's really warm. Magma is going to cool quickly when it comes out of and lays on the top of the earth, where it's cooler. So it's going to cool more quickly, and then the crystals in it are going to be smaller. And usually when water evaporates, we get minerals dissolved in that water. So when water evaporates, it'll leave those minerals behind as well. So let's see here. So here are the physical properties of a mineral: color, luster, streak, hardness, and cleavage. So I sent you guys a chart. If you were able to print that chart out, great. Now get it out. If not, this is what it looks like. You can just look at this one. You can write it down on paper if you want, or you can just observe. So these are the physical properties right here listed on this chart: color, luster, streak, hardness, cleavage. Color, luster, streak, hardness, and cleavage. We also have acid reaction on here. So we'll talk about each of these. So think about a color. What kind of colors do minerals come in? Larissa.
Purple.
Purple's one, yeah.
Also, mine is not X'd out on acid.
Oh, that's okay. That's fine.
Cleavages.
Mia.
White and black.
White and black, yep. Enoch.
Blue.
Blue, yep. Arthur.
Almost any color.
Really, almost any. Comes in almost any color. You're right about that. All right, what do we mean when we say luster? What does the word luster mean? Basically, it means how shiny something is. If something has a lot of luster, it's very glossy, very shiny looking. And then there's hardness. That just means how hard it is. Color streak is the color it leaves behind when you scrape it on a piece of ceramic. Like if you've got the kit, you got this little square thing, and that leaves behind a streak. And then we'll talk about cleavage and acid reaction. So we're going to test our rocks. So we're going to use the same tests to find out that the same ones that scientists use. They use these same kind of tests to determine what a rock is. So the first thing we're going to do is we're going to look at the color. So pick up any one of your minerals or your rocks if you got some from outside. We're going to call this rock number 1 on your chart. So I'm going to look at my number 1 in my thing, and my number 1 is green. It's a real pretty kind of sea green color. So look at your rock and write down on your chart what the color is. So right here in number 1, I'm going to write green.
You glitched. What did you say?
Oh, sorry. I'm going to write green because my color is green. Oh, that's terrible. I'm going to erase that and try it a different way. One of my problems is when I annotate. Let me try this. I have one of these drawing pads, but it doesn't always work. Oh, I think I need to turn this off and put it over here. Nope. All right, well, that's not gonna work. So we're just gonna, you can write green. Write whatever color yours is on that chart. Arthur. Did you have your hand up, Arthur? No? Okay. All right. So write down the color next to the number 1. Now your rock might have more than one color in it. Anybody have a rock that has more than one color in it that they picked up? Dominic, what do you have? Like gray and white? Yeah, there's no?
It's rainbow.
Oh, well, cool. Well, you can write down all the colors. You can just write down multi. You can write down rainbow. Basically, write down what you see. Your rock might have a little bit of red in it. Anybody have a rock that has a little bit of red in it? Do you know what that red is, if you have it? Arthur?
No.
No? If it has red in it, it's probably rust. So if it has rust in it, it probably has some of the mineral that we would call iron in it. So when iron comes into contact with oxygen in the air, rust forms. So there may be some of the iron, maybe one of the elements that's in that. All right, now the thing about color is that I don't understand here. I'm having a problem.
I can probably the annotate button's on, and I can probably write green for you.
Yeah, I'm trying to, there we go. No, that's okay. Thank you. It's okay. I appreciate it. But I'd have to keep switching back and forth, and it's a little, something's happening with my computer here. All right, so here's the thing about color. Color can be misleading because some minerals will have a similar appearance, but they might have some impurities in them. And those impurities can change the color. So color and appearance alone aren't enough to tell us what the mineral is. We need to look at different things too. And another thing that we look at is luster. So you've also got luster on your chart there. The second column is luster. So luster is the way the mineral reflects light. Basically, how shiny is it? A metallic luster would be real shiny, like metal. A non-metallic luster would be dull, non-shiny, includes pearly, silky, glassy. Those are all like non-metallic lusters. And then we can also use other terms to describe the luster, like waxy or pearly, glassy, dull, or silky. So take a look at your rock. Guys, I lost my rock already. I had that green rock. I put it down. Well, I'm going to pick up a different rock. All right, I'm going to pick up my number 12 here, but that's going to be my number 1. So that's got a real, can you guys see how shiny that is? That's really got a strong luster. So I would call this a metallic luster. That's what I would write there. If I had one like this one, this does not have a metallic luster. This is very dull in color. So that would be a non-metallic. Or I could use the word dull. I could use the word glassy on the first one that I showed you. Okay, so look and see if your rock is sparkly. If it's really got a lot of sparkle in it, that could be the same as having a metallic luster. So you can put letters down. You can put like N would mean that it doesn't have any luster. M would be a metallic luster. And then an N could be non-metallic luster, or you can write out the word. Khalil.
I have a question. I have a rock. It's another rock. Some parts of it looks like very shiny, almost like glitter, like it sparkles, but then other parts that's really not shiny at all. Uh, what's the why is that?
So remember that a mineral, if you've got, is it a rock or a mineral? Did it come in a kit that said minerals, or did you pick it up from outside?
I just picked it up from outside.
Okay, so it's probably a rock that would have different minerals in it. So it can have mineral that is shiny right up against a mineral that's not shiny. One that's sparkly and glittery right up against one that's not. And even minerals themselves have different elements in them. So some elements are shiny while other elements are not. So what you have, there's a mixture of either different minerals or different elements in that mineral. Yeah, that's pretty typical. I've actually got several of mine. I've got one right here in my mineral kit that has places on it that are real shiny, and then other places that are not shiny at all. Like that side doesn't have much shine on it at all. So yeah, that's very typical. Good observation. All right, the next thing that we're going to test now is going to be hardness. That's your third column. Now we can test the hardness of our rocks using what's called a scratch test. Hardness tells us how easily it scratches. And we have a scale that we use. It's called the Mohs hardness scale. So something is going to be really soft. It's going to have a 1 for its softness on the Mohs hardness scale. Something that's really hard is going to be a 10. Now, we can test the mineral to see how hard it is by using different things to scratch it. Now, if you have the kit, you might have a nail in there. You can use that to try to scratch it. You can use your fingernail. There are some minerals that are so soft that your fingernail will scratch it. So if a rock is softer than your fingernail, we know it has to be lower than a number 2 on the scale, on the Mohs hardness scale right here. So that we've got 1 is talc, 2 is gypsum. So look at you might have one of these charts. If you got the kit, the mineral kit, you'll have a chart that looks like this. And if you see talc on there, pick up your talc. Mine is number 10 on my kit. It's white. And I can take my fingernail and I can scratch this. I have a little bit of it underneath my fingernail from scratching that because it is a 1. It's very soft. So it's a 1 on the Mohs hardness scale. All right, so to see, you test your rock that you just did, that your number 1, we're still working on the same rock. Test it to see if it can be scratched with your fingernail. If it can't be scratched with your fingernail, then we know it's a little bit harder. So we can try to scratch it with our nail. You can also use a penny, but I didn't have you bring a penny to class because I figured your kits would have nails in them. So you can take your nail and you can try to scratch it and see if it scratches with the penny or the nail. It's probably going to be like a number 5 or a number 6 on the Mohs hardness scale. Now let's talk about that talc, that number 1. So you guys may have seen talcum powder. Have you ever heard of talcum powder? They used to use that for babies. They would use it when they would powder a baby. Talcum powder is actually the mineral talc. It's actually bits of like rock, really rock dust. So be careful if you ever use talcum powder, don't breathe it in. You're actually breathing in rock dust. All right, Larissa.
Mine, my penny, my nail, and my fingernail won't scratch this at all.
Okay, so that's going to be harder. So that's going to be something that is, I'm looking here to see like what the, let me pull up. I didn't get it. I meant to get a picture of this, but just give me 1 second here.
It's really smooth. So like,
Okay, I'm going to add this and show you guys what the Mohs hardness scale looks like. Thank you for your patience. Okay, so right here, take a look at this. So this is the Mohs hardness scale. So if taking your steel nail doesn't put a scratch in it, it's harder than a 7. So you can put 7+ on there. We're not going to be using drill bits to determine the hardness of our minerals. We're only going up to the 6.5 there. And we're not going to use glass or knife. You can use those, but there's a little bit of danger in using a knife with the rock or a piece of glass with a rock. So you can see down here, if it scratches with a fingernail, it's going to be between 1 and 2. If it's scratched with a coin, it's going to be like 2.5. A steel nail is going to be a little more than that. It's going to be like a 6. So anywhere close in there is fine. Interestingly, a number 10, see here on the scale right here, a drill bit is 8.5. There is something that is a 10. It's a diamond. A diamond is a 10 on the scale. You do not have a diamond in your kit, I promise. They wouldn't have put a diamond in your kit that you get on Amazon. But diamonds can scratch anything. They are so valuable because they're so hard. They can't be scratched by anything except another diamond. So, Arthur.
I was about to say diamonds can't be scratched by anything but diamonds.
Right, that's right. That's right. Now, sometimes diamonds are even used on saw blades. They'll put diamonds around the edge of a saw blade because they are so hard. So I didn't have you bring any diamonds to class because we're not going to test diamonds today and try and put a scratch in them. Larissa.
how much does that cost?
A diamond saw blade?
Mm-hmm.
They're more expensive than other ones, but they're not outrageous because what they do is they use like diamond flakes on the outside. The bigger a diamond is, the more expensive it's going to be. So if they're just tiny little bits of diamond, that isn't going to be as expensive as something that is like a larger diamond, like you'd have in a piece of jewelry.
Oh,
Yeah. So let me look here a minute. I can get a diamond saw blade for about $20. I could order that. So yeah, they're not all that expensive. And they last a really long time. Diamond saw blades, because diamonds, like I said, they're hard. They last a long time. That's part of the reason that diamonds are so valuable. All right, the next thing that we're going to test is what we call streak. So if you got that mineral kit, you'll have this little flat plate. It's called a streak plate. It's a little ceramic tile. If you went to the like a hardware store, you could have gotten a ceramic tile. If you used one of those ones from the hardware store, the back of the tile is unglazed. It's not shiny, and you could use that as your streak plate. Now, the streak plate is harder than most of your rocks. So when you rub your rock on the streak plate, a fine powder from the rock is going to come off, or from the mineral is going to come off. So geologists can really tell a lot about a mineral by the color that it leaves behind on the streak plate. So take your rock and scratch it. Boy, I wish I could find my green rock. How can you lose something sitting at your desk? It's probably on the floor. All right, so pick up your rock and scratch it on your plate and see the color that it leaves behind. Write down the color of the streak. If there wasn't any color, then write down no streak on your plate. Now, if your rock is harder than the streak plate, there won't be any mark at all. Non-metallic rocks usually give us a really light colored streak, or metallic rocks give us a dark colored streak. All right, so the color of the streak can be different than the color of the mineral. Minerals have to be softer than the streak plate is. All right, now I didn't have you do this with the other ones. We've been working on the same rock or the same mineral this whole time. What I want you to do now is pick up different ones and try them on your streak plate. So pick up the darker colored ones and see if they leave a darker colored streak. Here I have hematite, and that's not leaving any streak. Oh no, it is. It is leaving a streak. It's leaving like a dark red streak. And then I can pick up another one. This one is muscovite. That's not leaving me any streak at all. Yeah, colorless. If I look at my chart, it says colorless. So this chart will tell you what color streak you usually get. So I'm going to look at one here. Number 8, this is magnetite. You can see I have no color on my streak plate. I'm going to rub this on there and look at the line it left behind. So it's softer than the streak plate, and it is leaving behind a black streak on there. Now, once you're all done testing the streak color of all of your different minerals that you have, well, there's another one, left a really nice dark streak. You can use a regular pencil eraser to get rid of those streaks. You can just erase them right off of your streak plate, so you can use it again and again and again. Now, one thing streaking can do is it can help us to identify quartz. Remember I said that color doesn't, color is tricky because you can't necessarily tell something what it is by the color. Part of that is because quartz comes in a lot of different colors. Quartz comes in clear or purple or black or green or multi-different colors, but it always leaves a white streak. So if you have quartz, you can look at your paper that you have here. So mine has quartz as being number 5. It is milky colored, white. So I'm going to find my number 5, and it's always going to leave a white streak. So I'm going to scrape this, and I'm going to see that it left a white, a white streak behind. Let's get that. Here we go, Larissa. Yeah, look at the white streak on there.
Mine started off with a gray, and then I pushed it, like I did it like one more time over it, and it became like orange. Like,
oh, that's
gray,
cool. Hold
then,
it up, let me see. Oh, that's very cool. You got like an orangish streak. Cool. Arthur, hold yours back up again too. Oh yeah, look at all those streaks. Awesome. So if you're a geologist, you know what color streaks different minerals leave behind, and you can use that to help to identify your minerals. So what you guys can do after class is over, you can just do close your eyes and pick one and not know what it is, and you can do the color test, and then you can do the streak test, and you can do the luster test. And you can see if you can then figure out, you looking at your chart, which one it is that you have. You can try to identify. You can do the same thing with rocks that you got out of your driveway. You can figure out what kind of minerals they might have in them by doing these same kind of tests, because this is just what a scientist out in the field is going to do. Now they've got more, they've got more tools than we do here. So for example, they're going to have a steel knife and they're a nail, and they're going to have a knife or glass. They're going to have a drill bit. They're going to have specialized tools that help them to be able to determine what the different things are. All right, so let's look last at what we call cleavage or fracture. It is the way a mineral breaks. So these minerals break in a certain way. They could break along smooth, flat surfaces where every fragment has the same general shape. Or they could break randomly with rough, jagged edges. So I have a piece of paper towel, or a piece of, paper towel here. So I'm going to show you guys what I mean by cleavage. So I'm going to tear this piece of paper towel sideways. That tore pretty straight. That tore pretty straight up and down. If I tear it the other way, it's a little bit more jagged. It's a little, see, it's not quite as straight a line. And if I were to use the same thing with a Kleenex, I can see tearing it in one direction, that tears pretty straight. But if I tear it in the opposite direction, this way, yeah, it doesn't tear straight at all. That's called cleavage. So minerals have cleavage lines too. We were tearing the paper towel and the Kleenex along the cleavage line. It tore nice and straight. When I tore it the opposite way, that's where it went off to the side. So minerals are like that too. So geologists test their minerals to see if they have a cleavage line. If they do, they're going to break. They're going to leave a flat edge. If they don't, they're going to be more jagged. Now, we're not going to do that because it's dangerous for us to break rocks. They take hammers and try to break their rocks. We're not going to do that because pieces could fly up and hurt you. So don't test that. But this is one more test that geologists have in order to be able to figure out what different rocks are and what minerals are in the different rocks that there are. All right, the final one is the acid test. So we're not going to do this one. That's there should be X's. You could right now put X's all the way down. That just means we're not going to do it. So because we're not going to be dropping hydrochloric acid, it's a very, very, very strong and dangerous acid. So they drop that on there to see if there is any kind of a reaction to that. If some minerals will react to acid and some will not. So we're not going to test that, but it is something that scientists do. All right, now there's also some physical properties that can be used to identify minerals. Things like, does it glow under ultraviolet light? That would be this fluorescence right here. So the same fluorite sample here is shown under white light and under fluorescent light. So if you guys have any fluorescent lights at home, you might try that. You might try going into a room in the dark with just a fluorescent light or a black light and shine it on your rocks and see what kind of results you get. Another thing, that this acid, sometimes they will fizz even when a weaker acid is dropped on them. So a weaker acid would be like vinegar or lemon juice. Those, you might get a reaction from those. They might have optical properties. That means that if you place it over a picture, you'll get a double image of something. So like my number 15, which in my book is gypsum selenite. It's clear like that, looks like a little piece of broken glass. If I lay that over one of my words that's on my page, it'll give me a little bit of a double image like that. So that's one way that they can help to test and identify minerals. Radioactivity. So minerals that have either radium or uranium in them, you can use a Geiger counter to be able to find them and then to identify them. Some of them are magnetic. So magnetite and pyrrhotite are both natural magnets and attract iron. So take a look and see if in your kit you have magnetite. So I do. It is number 8 in my kit. So I have a magnet here, and I'm going to show you guys how it sticks to the magnet right there. So my other ones don't. My talc does not. But some minerals have natural magnetic properties to them. So these are the ways that scientists, geologists will identify minerals and identify the minerals that are in the rocks. Remember, minerals are ingredients in rocks. Rocks are made of minerals. Okay? All right, you guys can do the same thing after class. If you want to test all your minerals, go through your whole kit. These are just kind of fun to learn to identify, so play with them a little bit if you can, and you know, enjoy having a little rock collection there. Any questions about the minerals and minerals test? All right, I think we have time for a Kahoot today about minerals. So let's do that real quick. So it is right here. www.kahoot.it. I'll put it in the chat box. Right there. And our game pin is going to be 644-574. 644-574. Two, three. Got 4 people not in. 3. See what you remember about minerals. All right, 5, 4, 3, 2, 1. Here we go. Minerals that form from magma form from the result of what? Crystallization. Very good. Remember, if it cools quickly, it's going to be smaller crystals. If it cools slowly, it's going to be bigger crystals. Okay, that's no problem. You can always join. Remember that the game pin is always at the bottom too. Which of the following subatomic particles has no charge? No charge. We talked about this earlier in the year. That is a neutron. Neutrons are neutral. Protons are positive. Neutrons are neutral. And then an electron is negative. All right. Khalil, Ruby, and Mina for second and third. What is the smallest particle of matter? It is an atom. Excellent. Everybody got that one. Question 4. What are the building blocks of minerals? Elements are the building blocks of minerals, all the different elements. Remember I said that they have a specific composition of those elements that they're made of. Question 5. The tendency of a mineral to break along flat, even surfaces. What do we call that? That's cleavage. Excellent. The subatomic particle responsible for chemical bonds. Which part of the atom is responsible for the bonds that form? That is the electron. They're on the outside of the atom. That's an easy way to remember that. They're on the outside, so they're the ones that bump up against other things and can form a bond or not. The color of a mineral in its powdered form is referred to as, there's a hint on the picture there. Yeah, streak. That's the streak. All right. True or false? Minerals are generally organic.
My power went out for a second.
Oh no. That's so frustrating when that happens. That is false. One of the characteristics of a mineral is it has to be inorganic. It has to be made of something that was never alive. Which of the following is not a characteristic of a mineral? Liquid. Liquid. Minerals have to be solid. Can't be a liquid. Question 10. What do we call the uneven breakage of a mineral? That is a fracture. So cleavage is the plate that we have. That would be where it would be an even, smooth side. Uneven would be a fracture. True or false? Different minerals have different streak colors. That is true. That is true. We saw that when we drew them on our plates. True or false? Minerals have a definite chemical composition. That is true. That's one of the characteristics of a mineral. Question 13. What is the hardest mineral? A number 10 on the Mohs scale. A diamond. Yeah, diamonds are number 10. When magma cools quickly, the crystals are big or small? They are small when it cools quickly. They just don't have time to form larger crystals because they're cooling quickly. Excellent. The softest mineral would be what number on the Mohs hardness scale? A number 1. Yeah. Review. Are these lines of latitude or longitude? Climb up them like you're climbing a ladder. Latitude. Review. The USA is in what latitude? Latitude. Remember latitude. Latitudes are north and south, right? Because climb the ladder. Yeah, so it's going to be in the northern latitude, above the equator. Are these lines of latitude or longitude? Longitude. They're lines of longitude. All right, we're going to have to go quickly here. The USA is in which longitude? So if it was in north latitude, which longitude is it going to be in? It is in the west. In the west. Question 20. Which layer of the earth is the thinnest? That's the crust. You got it. 21. What does GPS stand for? Good pizza sauce. Global Positioning System. 22. All the stuff in the universe is known as matter. Matter. Remember, mass is the number of particles that something has. Matter is what we call anything that has mass and takes up space. Sorry, everybody. Thought I had that turned off. All right. Couple more. Multi-select, so pick more than one. The parts of an atom's nucleus. What's inside the nucleus of the atom? A proton and a neutron, not an electron. Electrons are not in the nucleus. They're going around the outside of the nucleus. 24. The measure of the amount of matter in a given space is called what? How much matter there is in a space. That would be the density. How tightly packed that matter is density. All right, one more. The most common state of matter in the universe is solid, liquid, gas, plasma. It is plasma. Plasma. Remember, stars are made of plasma. Plasma makes up about 98% of all the matter in the universe. 98%. Yeah. But there's not a lot of it on Earth. So that's why. All right, let's see how we're doing here. And then it's time to go. So our podium, third place, Enoch. Very good. In second place, Khalil. So who's our leader? Who's in first place? All right, Mina. Very good. Great job. Any questions, anybody? All right, have a terrific week. Thanks for coming. I'll see you next time. Bye, everybody.
Thank you for
Bye.
class.
Bye.
Bye.
Thank you.
Bye.
Bye.